Okay, today we're going to talk about radical equations. Radical equations are equations that have the radical sign. Maybe I should go back to the beginning. Okay, a radical sign is a sign that looks like this. And in the radical sign, we have the radicand. And we have the index. And then we have the radical sign. Now, if the index, which they have denoted right now as an n, is an even number, then the radicand inside must be greater than or equal to 0. It has to be a positive number or we get an imaginary number. And we did talk, and you're coming up to complex numbers and what happens if there is a negative under an even index. But right now, if there's a negative under an even index, we cannot do it. If n is an odd number, 3 or higher, then it can be any number under there, including a square root that is negative, I mean a root that's negative. So, here we got the fifth root of negative 2. Now, how do we do a fifth root? Well, it depends on what calculator you have. If you have this calculator that I have here, it's going to be under your math button. You're going to hit 5, telling you to do the fifth root. You're going to go to your math button and you're going to go down and you're going to go to the fifth one that says x and then the radical sign. That tells you the calculator the fifth root of negative 2. And since it is a negative number under the root, but the index is odd, it does come out as an answer. The next one is the square root of 2. And then the next one is the third root. On this calculator, you have a third root. It's the fourth one down. So it's the fourth one down. And I wanted the fourth root of 8. And I open parentheses, close them, which is 2. Now, I can also do the third root of negative 2 because if an index is odd, a negative can be under the radical sign. Well, maybe I should put the right number in. So let's hit second enter and go back and put negative 8 in instead of 2. So I'm going right straight to the answer. Now, if you have a calculator that is not the graphing calculator, for your root buttons other than your square button, unless you have a cubed root button on your calculator, you're probably going to have to hit the second button and you'll be looking for something that x to the y or y to the x. Then you'll put it in the same way. So if it's a third, it'll be 3. Then you'll hit that button, and then you put in negative 8, and out comes negative 2. Or you hit 3 and that button, and you put in negative 8, and out will come negative 2. So you have to look around for your buttons. If you can't find them, you can always email me. Okay, the identity property. Identity property says that if I'm taking a root of a times b, I can split a and b into their separate radicals. And if I am taking a root of a divided by b, I can split them into their separate radicals. And it's important because I'm going to be using that. Okay, when simplifying an expression using the exponents form, as in x to 1/3, normally it makes it easier to cancel out the powers and the roots. Okay, here's what you need to know. We need to be able to change from this form to this form, and from this form back to this form. Okay, so 25 is my base. That goes under the radicand. 1 is my numerator. The numerator goes right here. And 2 is my denominator. That becomes my index. If you do not see an index, it means that there's a 2 there. So this means the same thing. We need to be able to go back and forth. Okay, base is 8, numerator is 5, index is 3. Numerator, denominator. Denominator goes at the index, numerator goes inside as the exponent. Base is 256. Numerator's 3, denominator's 4. This one I'm going to use the property, I'm going to do them separately. base is 8 and 27. The numerator, oh, I have to do it the other way. Base is 8 and 27. The numerator would be -2, and the denominator would be 3. It's already in that form. Or I could have split them separately. If I would have split them separately, I'd have 8 to the -2/3 and 27 to the -2/3. That's okay also. So we're going to be switching back and forth a lot, so you need to get used to that. Okay, a negative exponent we learned earlier says, I'm in the wrong position, please move me. If I'm in the numerator, take me to the denominator, my exponent becomes positive. If I'm in the denominator, take me to the numerator, and my exponent becomes positive. Here's a review. Okay, this says, first of all, you have to remember that 1/2 power is the square root of x, 1/3 power is the cubic root of x, 1/4 power is the fourth root of x, and so on. So I want the square root of 36, but it's a negative exponent, so it says it goes to the bottom. So the square root of 36 is plus or minus 1/6. Now, if I only want the primary root, it would be 1/6. If I want both, it would be plus or minus 1/6. Okay, so this says the third root of 27 squared, but it needs to go to the bottom. 27 squared is 27 times 27, which breaks into 3 and 9, 3 and 3, 3 and 9, 3 and 3, so I can pull out 2 sets of 3's. 3 times 3 is 9, so I'll get the third root of the square root of 3/1. I'm happy with this part so far, because we haven't gotten to simplifying radicals yet. In this case, only the a is the one that's moving, so the 6 is staying on the top, and a to the 5/4 is going to the bottom. Or 6 is staying on the top, and the fourth root of a to the 5th is going to the bottom. (32) has a little 1, so it's 32 to the 1/5, a to the 6/5, if I'm pulling it out. 16 has a little 1, a has a little 1, so it's 16 to the 1/2, a to the 1/2, b to the 2/2, or 1. Little 1, 32 to the 3rd, x to the 2/3, y to the 3/3, which is 1, z to the 5/3. Now remember, we're just practicing moving things into the right position and doing them. Okay, x to the 7th goes to the top, x to the 3rd goes to the bottom. 7 x's on the top and 3 x's on the bottom gives me x to the 4th. -5 times -2 is positive 10. They stay on the top because they have positive exponents. X squared goes to the bottom, x cubed goes to the bottom, y stays on the top, and y squared stays on the top. So I get 10y to the 3rd, x to the 5th. 8 to the 1/3, a to the 2/3, b to the 4/3. 8 to the 1/3 is the same thing as the third root of 8, which is 2. A to the 2/3, b to the 4/3. If the bases match, keep the base and add the exponents, but the only way to add the exponents is to have a common denominator. So I'm going to need to switch these. I multiply this by 5, this by 5, this by 4, this by 4, so I get 31/20, or the 20th root of a to the 31st. We're practicing moving. Bring in, bring in, bring in, bring in, bring in, bring in. 4 to the -1, x to the 4/9, y to the -14/12, over 2 to the 1st, x to the negative 2/9 and y to the 6/12. So let me write that over here again so it's much easier to see. So I have 4 to the negative 1, x to the 4/9, y to the negative 14/12. And I know 14/12 reduces, but I want to leave it that way because I'm going to have to move things around and combine things, and it'll be easier if the denominators match. Right now, all the x's are in 9ths, and all the y's are in 12ths. Okay, 4 to the first, negative 1 goes to the bottom, the 2 stays on the bottom. X to the 4/9 stays on the top, x to the 2/9 come up. 2/9 and 4/9 is 6/9. X is 6/9 is 2/3. Y to the negative 14/12 goes down. 6 plus 14 is 20. 20/12 is 10/6, which is 5/3. So y to the 5/3. So I have x to the 2/3 over 8 y to the 5/3. And the bases match, so I keep the base, I add the exponents. The exponents have a common denominator. 1/2 plus 3/2 is 4/2. 4/2 is 2, so my answer is 25. So we're practicing a lot of things. We're re-practicing our negative exponents and our combining of exponents and simplifying exponents, as well as once we have them in exponent in a fractional form, we can then change it to a radical. Okay, so this becomes the 3rd root of 1,000, and then this is moving up to the square root of 400. The 3rd root of 1,000 is 10, the square root of 100 is 20, so I get 200 as my total. X to the negative 1/3 when I multiply these two. Y to the negative 3/8. X to the 1/3 goes down, y to the 3/8 goes down. Or 1 over the 3rd root of x times the 8th root of y to the 3rd. Just practicing making the moves. Bases match, add the bases, so I need to change this. So I get 9/4, 8 to the 9/4 over 8 to the 5/2. This needs to change to 4ths, 10/4. So if I have 9/4 on the top and 1/4 on the 10/4 on the bottom, I'll be left with 1/4 on the bottom, or 1 to the 4th root of a. And that is an a. Multiply in x to the 112 over x to the 2/9, common denominator 36. So 336 on the top, 836 on the bottom. So I multiply by 4, gives me 536 on the bottom. So 1 over x to the 536. Or 1 over the 3rd root of x to the 5th. Remember, there's a little 1 here. Bring it in. 2 squared, a to the 2/3, b to the 4/3. So I have 4, a 3rd root of a squared, times the 3rd root of b to the 4th, so I can put them both under the same root. So 4, 3rd root of a squared, b to the 4th. Now, we didn't reduce any of these or rationalize the denominator. That's coming up. All we're doing is practicing our negative exponents, practicing changing something from an exponential to with a fractional exponent to something that is into a radical, and back and forth. Okay, factor out the common factor of a given expression. And they want me to take out 1/4. Anytime you take something out, you're dividing it. When you're dividing and the bases match, you subtract. So 5/4 minus 1/4 is 4/4, or 1. Minus 4/4, 1/4 minus 1/4 is 1, minus 5. Take out x to the 1/3. 5/3 minus 1/3 is 4/3. X to the 1/3 minus x to the 1/3 is 1 plus 7. Remember, when you're taking out in a distributed property, you're dividing. If the bases match, you subtract the exponents. Okay, now we're going to simplify radicals. Okay, here is the big thing. We need to know what the index is. This index is 2. Even though we don't see it, it's 2. That means we need a pair of anything to get out. So I have A, B, B. I have one pair of A's, two pairs of A's, so I can pull an A squared out. And I have a pair of B's, so B can come out. Nothing left under, so I'm done. I need to break 75 down into its prime factors. 3 and 25, 5 and 5. I'm only worried about the factors at the bottom. These were already split. I have one pair of 5s, and I need a pair to get out, so the 5 can get out. The 3, on the other hand, does not have a pair, so it must stay in. I have an X, an X, and an X. I have a pair of X's, so an X can come out, and I have one X left in. Y, 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 Y. Two pairs of Y, so Y squared can come out, and a Y stays in. This is reducing. It's almost like when you reduce a fraction. You've got to get it into simplest form. This is simplest form. You are going to be required to put everything in simplest form. 2 and 100. Now, some of you might have took 5 and 40. It doesn't matter. You're still going to get down to the same thing. I always circle the tips so I know what I'm looking at the end. Anything that's not circled has already been used. So I have a pair of 2s and a pair of 5s. 2 times 5 when it comes out will be 10. Left inside, I use this pair of 2s and this pair of 5s, so there's a 2 left inside. I have 2 A's, so a pair of A's come out. I have 5 B's, so 2 pairs of B's come out and a B stays in. And I have 3 C's, so a pair of C's come out and a C stays in. Now, you don't have to list all those out like that. I'm doing it so you can see what I'm doing. If it makes it easier on you, do it. Okay, notice I'm switching indexes. Now I need 3 of a kind to get out. 25 times 10. 5 times 5, 2 times 5. 5, 5, 2, 5. Gone, gone, gone. I have 3 5s, so 5 can get out. Don't forget to leave the index in here. It's important. And a 2 stays in. R, 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 R. So I have a pair, triple R that can come out and an R that has to stay in. I have S, 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 S. I have 3 S's here, 3 S's here, and 3 S's here. S cubed can come out, and S stays in. And I have 15 T's. So I'm going to pull out 1, 2, 3, 4, 5 groups of T's, no T's left to stay in. It's important that you make sure that index goes along with your answer. Okay, this is an odd index 3, so this negative can come out. It's okay. 40 breaks into 4 and 10, 2 and 2, 2 and 5. Cross, cross, cross. I have 3 2's, so a 2 comes out. Don't forget my index, the 5 stays in. I have 6 X's, so 2 groups of 3. So an X squared comes out, no X's stay in. Switching indexes, I need 4 of a kind to get out. So 2 and 81, 9 and 9, 3 and 3, 3 and 3. I have 4 3's, so a 3 comes out. Don't forget my index on my radical. And I have a 2 that's staying in. I have M, 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 M. So I have 4 M's, so an M comes out, an M stays in. And I have 2 N's, can't come out. There's my answer. A little space in between. Now, every time I see a radical, I have to ask myself, can it break down? So I have a radical of 20, and I have 2 and 10, 2 and 5. I have a pair of 2's, so a 2 can come out. So I have 4 minus 2 square root of 5 over 2. 2 goes into 4 twice, 2 goes into 2 once, 2 goes into 2 once. So 2 minus the square root of 5 is my answer. I have a square root. 9 and 5, 3 and 3. The 3 can come out, so 6 plus 3 square root of 5 over 3. 3 goes into 6 2 times. 3 goes into 3 1 time. 3 goes into 3 1 time. 2 plus or minus the square root of 5 over 1. 32 breaks into 2 and 16, 4 and 4, 2 and 2, 2 and 2. I have 1, 2, 3, 4, 5 2s. They're gone because I broke them down. So I can bring 2 pairs of 2s out. 2 times 2 is 4. Square root of 2 inside with a 4 underneath. Now, 2 can go in all of them. So this will go into -1, this will go to 2, and this will go to 2. So -1 plus 2 square root of 2 over 2. Or you can split it up and make it -1/2 plus 2 divided by 2 is 1 square root of 2. Either one is acceptable. Okay, multiplying radicals. Here's what you need to know about multiplying radicals. They must have the same index. So these two both have a 2, so that's fine. Then I can just multiply because they're both under a radical. Square root of 3 times square root of 15 is square root of 45. 45 breaks into 9 and 5, 3 and 3. I have a pair of 3s, so 3 comes out, 5 stays in. They have the same radicals, so I can just multiply under it. I mean the same index. So 4 times 2 is 8. X times x to the 4th is x to the 5th. 2 and 4, 2 and 2. I have 3 2s, so a 2 comes out. I have 5 x's, so an x comes out. And 2 x's stay in. Dividing. Dividing is the same. You have to have the same index. So the square root of 3 times the square root of 15 is the square root of 45, and the square root of 45 divided by the square root of 5, 45 divided by 5 is the square root of 9. The square root of 9 is 3, and we're only using primaries here. Third root. 81, 20 square, third root of 27 into the third root of 81 is a third root of 3. Because 81 divided by 27 is 3. I cannot take the third root of 3 and break it down. Notice these are on the outside, so I reduce them. 18 divided by 3 is 6. And the third root of 30 over the third root of 10 leaves me the third root of 3, which cannot be broken down. Square root of 8,820 and the square root of 180. 8,820 divided by 180 is 49, so it's the square root of 49, which is 7. Like I said, we're only using primaries. Now, I told you can multiply radicals if they have the same index. What if they don't? This has an index of 3 and this has an index of 4. Well, I need to get them to a common index, which would be 12. So I multiplied by 4 here, so I have to put a 4 in here. I multiplied by 3 here, so I have to put a 3 in here. So on the outside now, my radical is 12, because 4 times 3 is 12. 5 to the 4th times 8 to the 3rd. Now, I always try to see if it breaks down here, because it's easier. I have 4 5s, and each 8 breaks into 3 2s, and I have 3 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9. I do not have enough to reduce. So, meaning that I can't pull out my 2s and I can't pull out my 5s. So 5 to the 4th power times 8 to the 3rd power gives me the 12th root of 320,000. And now I know it doesn't reduce. It's easier for me to reduce in the piece form than it is in the full form. Okay, this doesn't look like it has an index of all, but it has an index of 2. So common is going to be 6. So I'm going to have to put 2 in here and 3 in here. So the 6th root of 12 squared times 10 to the 3rd. Well, 12 is 2, 2, 3. And I have 2 of them, so 2, 2, 3. And 10 is 2 and 5, and I have 3 of them, so it's 2 and 5, 2 and 5. I have 1, 2, 3, 4, 5, 6 2s, so its 2 is coming out. Left hand side is a 3 times 3 is 9, times 5 is 45, times 5 times 5. So 45 times 5 times 5. 1,125. Let's see. 3 times, oh, I forgot that 2 is hiding in a 2. So, let me go back here. So I have 3 times 3 times 5 times 5 times 2 times 5. So 3 times 3 times 5 times 5 times 5 times 2. 2,250. Missed that 2 the first time around. So I can multiply and I can divide with indexes that don't match. I just have to get them into a common index and change the exponent inside to compensate for it. Okay, adding, subtracting. Adding and subtracting is just like adding and subtracting x's and y's. You can't add x's and y's. You can't add x squares and x's. So you have to have the same number under the radical, which is called the radicand. So I'm going to take the 20x and I'm going to break it into 2 and 10, 2 and 5. And I see I can pull out a 2. There's already a 2 on the outside, so 2 times 2 is 4. I'm left with a 5 and an x inside. Now I have 3 with a 5 and an x inside. So I have 4 square root of 5x plus 3 square root of 5x, which is 7 square root of 5x. The radicand has to match to be able to add them, just like x has to be matched with x to add them. The 3 doesn't break down, but I have 3 b's, so b comes out, third root of 3, minus 24 breaks into 2 and 12, 2 and 6, 2 and 3. I have a 2 that can come out, and a 6 that stays in. So 2 comes out, and I get 6b third root of 6. 81. 3 and 9. How about 9 and 9? 3 and 3. 3 and 3. You know what? I need to go back to that last one, because I made the mistake, which a lot of you are going to, is I forgot that I need 3 of a kind to get out and not 2. So I had 2 and 12, 2 and 6, 2 and 3. So I need to take all these 2's out, times 2. So b third root of 3 minus 6b third root of 3. 81. 9 and 9, 3 and 3, 3 and 3. Bring out a 3 plus 6. Bring out a b third root of 3. So I have the third root of 3, the third root of 3, and the third root of 3. So negative 6b and positive 6b will cancel out, so I'll get b third root of 3. Now, what would have happened if I would have gotten down to b third root of 3 minus 6b third root of 6 plus 6b third root of 3? Then these two would have went together, and this would not have. It would have been like an apple, orange, and a banana. Well, an apple and orange. So 6 plus 1 would be 7 third root of 3. They can go together because they have the third root of 3 minus 6b third root of 6. You just leave that on the back. So if they don't all go together, don't freak out. They don't have to. Okay, common denominator because of a fraction. Yeah. Break down. 4 and 4, 2 and 2, 2 and 2. I have 4, 2, so 2 comes out. So 2 fourth root of x. 5 plus 3 fourth root of x over 5 gives me 5 fourth root of x over 5. The 5's cancel out because they're both non under the radicals. So fourth root of x. Multiply. Remember, when we multiply, all we need, now we're going to be multiplying and adding and subtracting. So multiplying, we just need the same index so that we can multiply. So they all have 2 indexes, so I can multiply. So I get the square root of 6 minus the square root of 16. So I get the square root of 6 because 6 breaks into 2 and 3 and I can't pull anything out. And the square root of 16 is 4. FOIL. This really confuses some people because they don't know what to do with the numbers in front. Well, this has a 1, so take 1 times 3, which is 3, then take the square root of a times the square root of a, which is the square root of a squared. take 1 times 7 is 7. Square root of a times nothing is the square root of a. Negative 5 times 3 is negative 15. Nothing times the square root of a is the square root of a. Negative 5 times 7 is negative 35. Now, the square root of a squared disappears. So I have 3a. 7a minus 15a is negative 18 square root of a minus 35. None of these can go together, so I'm finished at this point. Okay, rationalizing the denominator. You are not allowed to leave a square root in the denominator, so you must rationalize it. To rationalize it, you have to get the square root to drop out. So, if I want a square root of 2 to drop out, I need to multiply by the square root of 2. Because the square root of 2 times the square root of 2 is the square root of 4. And 5 times the square root of 2 is the square root of 5 square root of 2. The square root of 4 is 2. I no longer have a square root on the bottom. If I need to reduce, and I cannot go in, this isn't a square root, this is not, so I can't reduce those two, then I get my answer. You are not allowed to leave a denominator on the bottom. So I'm going to multiply by the square root of 6. That makes the easiest sense. 4 times the square root of 6 over the square root of 36. The square root of 36 is 6. This 4 and 6 can reduce to 2 over 3 with the square root of 6. I can reduce the 4 and 6 because they're both outside of the radical sign. Now, to rationalize a denominator when you have a binomial, you have to multiply by what's called its conjugate. Now remember, x minus 2 and x plus 2 are conjugates. The reason they're conjugates are that if I FOIL it, the middles will drop out and I'll end up with x squared minus 4. That's what we're trying to do here, to get our middles to drop out. So my conjugate would be 1 minus the square root of 3 and 1 minus the square root of 3. So we get 2 minus 2 square root of 3 over, remember, first and last, the middles will drop out. 1 times 1 is 1. Square root of 3 times negative square root of 3 is negative the square root of 9, and the negative square root of 9 is negative 3. So this will become negative 2. No radical in the bottom. I'm going to reduce everything by negative 2, and I'll get negative 1 plus the square root of 3. The reason I use negative 2 is because I don't like leaving a negative in the denominator. So if I'd only used 2, I would have had negative 1 in the denominator. Conjugate x minus the square root of 3. So 4x minus 4 square root of 3 over, remember, first and last only because the middles are going to drop out, x squared minus the square root of 9. Square root of 9 is 3. Can't reduce, so it's finished. If you want to pull the 4 out of the top, you can, but you're still not going to be able to do anything in reducing. Conjugate of square root of 5 minus 6 is square root of 5 plus 6. Square root of 5 plus the square root of 6. Okay, square root of 10, square root of 12, square root of 15, square root of 18, over square root of 25, which is 5, negative the square root of 36, which is 6. So this becomes negative 1. I don't like leaving negatives in the bottom, so I'm going to change all the top ones to negatives and get rid of the negative 1 in the bottom then. So it's negative square root of 10. 12 breaks into 4 and 3, 2 and 2. So it's negative 2 square root of 3. 15 will not break down, so it's square root of negative 15. And 18 is 2 and 9, 3 and 3. So 3 comes out, so it's negative 3 square root of 2. None of the radicants match, so I'm finished. Okay. So now we're going to go back to function notation. It's not going to be any different than the lesson we did before. Go into the f function and put it in 5. So square root of 5 minus 4. Square root of 1. Square root of 1, remember we're only using primaries on this lesson, is 1. Go to the f, put in 13. So square root of 13 minus 4. So square root of 9, 3. Go to g and put in negative 3. The third root of 3 times negative 3 plus 1. The third root of negative 9 plus 1. The third root of negative 8, negative 2. Make sure you go to the right function. Now, domains of radicals. Remember I told you when we did domains and ranges previously that the domain is always negative infinity to infinity unless there is a denominator or a square root or a radical. Well, if there's a square root, we're only worried about the square roots. Okay, so this is a square root. Anytime you have a square root, you have to make it greater than or equal to 0. Why? Because it can't be a negative number. So if I move this over, x is greater than or equal to 5. So the domain is x is greater than or equal to 5, or 5 included to infinity. Now let's graph it and see if that makes sense. Y equals, clear that out, the square root, starts with my parentheses, x minus 5, graph it. Now see how it starts at 5 and it goes to infinity? That would be my domain. Okay, this is the third root. Now, let me graph it for you first so I can explain to you why I mean this. I'm going to go to math. I'm going to go to the third root. And I have 2x plus 1. Graph it. Now look, the left side goes to negative infinity. The right side goes to positive infinity. There is no restriction on a cubic root. Therefore, the domain is negative infinity to infinity. So let's look at the fourth root. Y equals the fourth root. See what that looks like. If that's going to be something I have to put a restriction on, or if it's just square roots. X minus 5 minus 2x. Put a parentheses, graph it. Oh, I need a parenthesis here. Now notice I didn't just clear it out. I went to go to find out what the mistake was. Does it look like it has a restriction? Yeah. It goes from negative infinity to 2/5. So this one has to, because we're only using the primary version, we have to take it because it has an even exponent and make it greater than or equal to 0. So move my 5. Negative 2x is greater than or equal to negative 5. Divide by negative 2. X is less than or equal to 5/2. Means it goes from negative infinity to 2.5 included. And if you look at my graph, it goes from negative 2/2 to negative infinity. So there's only a domain restriction on even indexes. On odd indexes, there's no domain restriction. It's negative infinity to infinity. Okay, so this is the square root graph, or the parent graph of the square root. Now, I wanted to tell you, every time you do something to this parent graph, it's going to move it one way or the other. Anytime you add to the parent graph, it moves it up. So this is moving it up too. Add to the parent graph, it goes up. So this one's up too. This, anytime you subtract from the parent graph, it goes down. So this is moving down too. Okay, anytime you add to the x. Now, here is our regular parent formula. Now notice, it's supposed to be minus underneath. This is plus underneath, which means I had to put a negative number in. So most people look at this and they say, oh, it's going to move right. No, it's going to move left, because you had to move left 2 because it was negative 2 that had to be placed in to make that negative h positive. So anytime you subtract from x, you're going to move right. So this is right 2. It doesn't change with whatever equation it is. I'm adding to the x, so it's left. and it'll be left 2. I'm subtracting from the parent graph. It's way back here. It's not in the parentheses with the x, so it's down 2. I am adding to the parent graph because it's not in the parentheses, so it's up 2. And I'm subtracting from the x, so it's right 2. Okay, radical equations. Anytime you have a radical equation and you want to solve it, you have to get the radical by itself. That's the first thing you have to do. Once the radical is by itself, you raise both sides to its index. You solve it, and then make sure it works. Okay, so I'm going to pick up the 2 and move it over. I get the square root of 3x plus 10 equals 2. It has an index of 2, so I square both sides. This is gone. I get 3x plus 10 equals 4. Move my 10. 3x equals negative 6. Divide by 3, x is negative 2. Check it. 3 times negative 2 is negative 6. Negative 6 plus 10 is 4. Square root of 4 is 2. 2 plus 2 is 4. Yep, works. Okay, I'm going to pick up the 7 and move it over. The square root of 5x minus 1 equals negative 2. Now, I can continue with this if I want to, and I will get an answer, but it's not going to work. And the reason I know it's not going to work is because I have an even index, and it equals a negative number. And an even index cannot equal a negative number. So this is no solution. What's going to happen is, if I finish this off, 5x minus 1 equals 4, add my 1, 5x equals 5, divide by 5, x is 1, and I plug it back in, I get the secondary root. Remember, we're only dealing with primaries here because only the primary will work in an equation, okay, with one answer. So as soon as you see a negative number, when the radical is by itself and you have an even index, you might as well stop and say no solution. Do not stop until the radical is by itself and that you check that it has an even index, because odd indexes can continue because positive and negatives are fine. Okay, radical's by itself, so I need to square both sides, including that one. This goes away and I get x plus 5 equals x minus 1 times x minus 1. I'm going to have to FOIL. X plus 5 equals x squared minus x plus 1. Now, you have to get everything to one side when you have a square term so you can factor. So this x is coming over, and this 5 is coming over. So I get x squared, negative x, negative x, negative x, negative 3x minus 4 equals 0. X minus 4 equals 0. X plus 1 equals 0. X is 4. X is negative 1. Now, I had a square root to start with, which means only one of them is the primary, the other one's the secondary. So one's going to work and the other one's not. So try them. 4 plus 5 is 9. The square root of 9 is 3. 4 minus 1 is 3. This one works. X equals 4 works. If I put negative 1 in, negative 1 plus 5 is 4. Square root of 4 is 2. Negative 1 minus 1 is negative 2. This is my secondary. It will not work back in the equation. Pick up my 4 and move it over. The fourth root of 3x minus 12 equals negative 3. It's by itself. It's a negative. It has an even index. There's no solution. It's going to give me the secondary root. Now remember, half is the same thing as the square root, so it might be easier to make it the square root squared. I move the 3 over. Goes away. 5x minus 1 equals 49, add 1, 5x equals 50, divide by 5, x is 10. 5 times 10 is 50, 50 minus 1 is 49, the square root of 49 is 7, 7 plus 3 is 10, works. These both have the radicals by themselves. I need to cube them because they both have the same index. So I get p squared minus 4p minus 4 equals negative 3p plus 2. I have a squared, so everything to one side. P squared minus p minus 6 equals 0. 1 and 6, 2 and 3. Subtract for negative 1. P minus 3, p plus 2 equals 0. P is 3, p is negative 2. Now this had an odd index. So the primary and secondary will work. Take my word for it. If I put 3 in and I put -2 in, they both work. So the answer is P equals 3 or P equals -2. I'm going to skip this one for a second and move over here. I'm going to extend my bracket and make a 1 because now I see cross multiply. So E, 1, extend it. E square root of n is equal to Z times O with a fancy tail, divide by E. Square root of n equals Z with an O fancy tail over E. Square both sides. Now please notice I'm squaring both the numerator and denominator. So it's going to be Z squared O fancy squared E squared, or ZOE quantity squared. Now why did I skip this one? Because this is a long one. Here's the reason why. Steps if you have 2 radicals in your equation. Get your radicals on opposite sides. So this has to go over here. So I have the square root of 3x plus 6 equals the square root of x plus 6 plus 2. Raise both sides to the index. Well, raising this side to the index is not going to be a problem, but this side is. This is going to go away and get 3x plus 6. But this is going to be square root of x plus 6 plus 2 times the square root of x plus 6 plus 2. And I'm going to have to FOIL it. So 3x plus 6 equals this times this will give me x plus 6. This times that gives me 2 square root of x plus 6. 2 square root of x plus 6. And 2 times 2 is 4. So 3x plus 6 equals x plus 10 plus 4 square root of x plus 6. Now I got one radical, and I have to get it by itself. So I need to subtract the x and subtract the 10. So 2x minus 4 is equal to 4x plus 6. I'm going to square both sides. So this becomes 2x minus 4 times 2x minus 4 equals 16. That squared goes away, times x plus 6. So I get 4x squared minus 8x plus 16 equals 16 times x plus 6. 4x squared minus 16x plus 16 equals 16x plus 96. Subtract the 16x, subtract the 96. 4x squared minus 32x minus 80 equals 0. Pull out a 4. X squared minus 8x minus 20 equals 0. One and 20, 2 and 10, subtract for 8, 2 and 10, so 4 times x minus 10, x plus 2 equals 0. 4 equals 0. Nope. X equals 10, x equals negative 2. Well, we started with the square root, so only one of them is going to work. So let's plug it back in and see which one. 3 times 10 is 30. 30 plus 6 is 36. So that would give me 6 here. 10 plus 6, 16. Square root of 16 is 4. Equals 2. 2 equals 2. This one works. That one doesn't. But a lot of work to get it down to where it's at. Okay? I won't give you one of those. But if I did, you should know how to do it. Okay, it's your turn now to practice.